Okay guys, this is Lewis, and in this video I'm about to teach you how to solve related rates problem. So let us begin. So basically related rates problem is it's basically about finding the relationship between variables, and common related rates problems are sliding ladder, changing volumes of a liquid in a certain container, or change in angles of certain segments over time. So as for now, you won't understand what all these means. You won't fully grasp what they mean, but as we work through the example problem, which we will do later, and you will see how these principles work out. And here, below, there is a very important statement, and it says, when you show the change in a certain variable, you take the derivative of the variable in terms of time t. So what I mean by that is, if you look, if you're trying to solve the related rates problem, in those problems there are gonna be, or in those situations, there's gonna be always gonna be some variables that are changing, and in order to represent those changing variables, you have to take the derivative of that variable in terms of time t. So here's an example. A equals pi r squared, and right next to it says area increases at the rate of 3 meters squared per second. So this is the generic equation of finding area of a circle, and as it is written above, we have to take derivative of A in order to show the change of area. So once we do it, we get dA over dt. So this is the result of taking derivative of A in terms of time t, and this is 3 meters per second. And if we take the derivative of the rest of the equation, we get pi just comes down because it's a constant, and we take the derivative of r squared, it will be 2r. So that's basically it. I'm not saying that this is all you have to do for solving the related rates problem, but these are the basics. Okay, so as for now, let's look at the strategies of solving the related rates problem, and we will work with the example problem afterward. Okay, so here are 7 steps of solving the related rates problem, and let's cover all of them one by one. Okay, the first step is draw the diagram. Okay, why do we have to draw the diagram? Well, once we draw the diagram, we have more. We can see more information than we did before we drew the diagram. So, yep, that's basically it. And for the second step, you have to find out what are the given data. So, when you look at the related rates problem, the problems are always going to give you the variables. They will always give you some variables, and you have to take note of those variables, and you have to keep record of them so that you won't forget them while you're solving the problem. And the third step is solve for missing parts at time t. Well, what I mean by that is, well, at the second step you got all these given data, right? So, well, you took a note of those data on the blank space somewhere, like next to the problem. And what you have to do, what you have to do next is use those data to find something that is not directly given in the problem itself. So that's yeah. So you have to use these given data and use them to find certain stuffs in the problem, certain other data in the problem that aren't directly given to you. So that's the third step. And let's go to the fourth step. And it says, what do you need to find with all the data you have so far? So in the problem, at the end, the problem is always going to ask, at what rate, for instance, at what rate is the water draining out of the cylinder? or at what rate is the bottom of the ladder sliding out. So you have to take note of what you need to find. You should always keep that in mind so that you can find the answer at the very end of the step, of these steps over here. And number 5, it says find the relationship between variables. So you've got all these given data, you've found all these indirectly given missing parts of the data, and you know what you need to find now. And with all these data and variables, you have to find the relationship between them. What I mean by finding the relationship is that you have to come up with an equation that kind of links all of these variables into one. So, yep, that's the 5th step. And the 6th step is taking the derivative. Once you've got the equation, you take the derivative of that equation, and you can plug in all these data and variables into the equation that you just took the derivative of. And the 7th step is solve for what you need to find. So basically, that's once you plug stuffs in there, you will obviously find what you have to find in the end. Well, I know, well, at first, once students see these without solving the problem, they would say, what are all these? But don't worry, we will work with the example problem, which is right over here. And it says, a ladder 10 meters long is leaning against a vertical wall with its other end on the ground. The top end of the ladder is sliding down the wall. When the top end is 6 meters from the ground, it is sliding at 2 meters per second. How fast is the bottom moving away from the wall at this instant? So here's a bunch of words, and you have to understand this to solve the related rates problem. And if you recall our 7 steps, I'll bring it back here. It says draw the diagram. Okay, so let's draw the diagram. Okay, the problem said a ladder 10 meters long is leaning against the vertical wall with its other end on the ground. So you have to draw a ladder leaning on a wall. So this is a vertical wall and horizontal wall. This is okay. This is the ladder, and this is the vertical wall, and this is the ground. Well, as for now, let's say vertical wall is y, and let's say the ground is x. Okay, the problem said when the top end is 6 meters from the ground, it is sliding at 2 meters per second. Okay, what was our second step in our strategy? It was, what are the given data? We have to write these given data on the separate space, and let's do that right now. Okay, it says when the top end is 6 meters from the ground, and it is sliding at 2 meters per second. Okay, so here it says, in other words, that means y is 6 meters, and it is sliding at 2 meters per second. Well, okay, here's another thing. If this is 2 meters per second, this is showing the change of height over time. So what do you have to do? You have to take the derivative of the height in terms of t. So let's do that right now. So dy over dt equals 2. So it's sliding down at 2 meters per second. And well, actually, I made a mistake. It's -2 because it's sliding down. It's sliding down, so it has to be -2. And yep, those are the given data. These are the given data. And the rest of the problem is how fast is the bottom moving away from the wall at this instant. Okay, so these are the given data, but what was our third step? Our third step was solve for missing parts at time t. That means we have to find out the information that is not directly given in this problem. So that would be, in this case, it would be finding the x. Well, how can we find the x? Let's look at this. So this is a triangle, and it's a right triangle because it's a wall and a ground. So what equation can we think? Can we come up with after looking at this diagram? Well, what should come right into your mind is the Pythagorean theorem. So x squared plus y squared equals, let's say ladder is L squared. So this ladder was 10 meters long, as it was given in the problem. So, and this is not the length of ladder is not going to change no matter what. It's just sliding down, and the length is never going to change. So we'll say this is 10, and obviously it will be 100. So x squared plus y squared equals 100. So now you have y equals 6 meters. So you can plug it right in here to find the x. And let's do that. So once you plug in 6 into y, it will be x squared plus 36 equals x squared plus 36 equals 100, and x would be 8. Yep. So here, after solving this equation, we've got indirect data, which is x equals 8 meters. Okay, here basically we've got everything to move on to the next step. So the next step was, what do you need to find with all the data you have done so far? What do we need to find? The question is asking, how fast is the bottom moving away from the wall at this instant? So it is asking how, like, the changing rate of x over time. So that would be, in other words, dx over dt. So our goal is to find this. And our fifth step is find the relationship between the variables. So what have we got? We got x, y, and a ladder here. So we have two variables and a constant, which is 10. And I think we actually already found it. We found it already, so it's over here. X squared plus y squared equals 100. So you're going to use this equation to find the dx over dt. Well, I'm running out of space, so I'm going to write over here. So x squared plus y squared equals 100. And what's our sixth step? It's take the derivative. You have to take the derivative of this equation so that we can plug the dy over dt and find the dx over dt by solving the equation. So let's do that right now. So if we take the derivative of x squared, it would be 2x times dx over dt plus here 2y times dy over dt, and the derivative of constant would be 0. And yep, this is the equation that we came up after taking the derivative. So there's x, y, dx over dt, and dy over dt. So what's our seventh step? Our seventh step is to solve for what you need to find. What do we need to find? You have to find dx over dt. So what do you have to do? You have to plug y equals 6 meter, x equals 8 meter, and dy over dt equals -2 into this equation so that we can find dx over dt. So let's do that right now. So 2 times 8 times -2 plus 2 times 6 times, I'm sorry, this is not -2, this is, you don't know, this dx over dt, and dy over dt is -2, so -2 would be 0. So that's what we've got, and let's find the dx over dt. So 16 times this dx over dt plus -24 equals 0. So 16 times something equals 24. So in other words, if we solve this, dx over dt would be 3 over 2. And that's our answer right over there. So we've got the answer. dx over dt is 3 over 2. The bottom of the ladder is moving away from the wall at 3 over 2 meters per second. Okay, so now that we found the answer, let's go over what we've learned so far. So let's go back to the first page. Here it says, I told you related rates is about finding the relationship between the variables. So here, these processes, here you wrote x squared plus y squared equals 100. Well, this is basically the relationship between the variables, and our goal is to come up with these equations to further solve the equation and get whatever we want. So I think that was clearly explained, and as it is written here, whenever we want to show the change of something over a period of time, we have to take the derivative of that changing variable in terms of time t. And we did that over here. dy over dt is -2 because y is, the ladder is sliding down the wall at 2 meters per second. And let's look at the strategies. It says draw the diagram. Well, okay, it's kind of crowded. Anyway, it says draw the diagram, and we did draw the diagram. And the second step was, what are the given data? We found the given data over here. And third step was solve for missing parts at time t. And we did that by using this equation, x squared plus y squared equals 100, and found the indirectly given data, which is x equals 8 meters. And our fourth step was, what do you need to find with all the data you have got so far? So what we were looking for was dx over dt, and our fifth step was find the relationship between the variables. So if we find the relationship, it would be x squared plus y squared equals 100, which is the Pythagorean theorem. And our last two steps will be taking the derivative and solving whatever we need to find. And we took the derivative, which is right over here, and 2x times dx over dt plus 2y times dy over dt equals 0. And we plug our data in here, and we came up with the answer. The dx over dt equals 3 over 2 meters per second. Okay, that's basically it. And I hope you learned how the related rates problems work itself out. And Thanks for watching. I'll meet you in other videos which would solve some few other examples. And so, see ya. Bye.